Hi, in this video, we want to take a look at the F test in terms of R squared. So remember, R squared is the sum of squares regression divided by sum of squares total. Okay, so if we're doing the overall hypothesis test, the overall model, we can look at R squared in this format: sum of squares regression divided by sum of squares total. Now, if I'm interested in R squared for a reduced model, it's very similar. It's just that now I've got the reduced model coefficients and I've got the reduced model predictor variables involved. Okay, that seems natural, right? All right, so now if I want to test for overall regression, so here the hypothesis is that these predictor variables, some collection of them, is informative to our target variable. All right, now that doesn't say that we're not that this makes no implication of being like a good model or overfitted, underfitted, or anything like that. It just says that there is good information inside these predictors. All right, so our null hypothesis is that the coefficient is the zero vector, and here this is the coefficient. This is the slope vector. This is not including the y-intercept. And the alternative is that the slope vector is not equal to 0. Okay, so if it's not equal to 0, then there is at least one slope that is useful for informing us to the target variable. Okay, so if we think about the F statistic, I've got this part here that looks kind of familiar, and we've got this part here, right? All right, now up top I'm divided by k, and down here I'm divided by n minus k minus 1. Okay, well, if I look at this, I notice that this is the numerator right there. So what I could do, I could replace this parenthesis with this numerator, which is equal to R squared times the denominator. So boom, I've got that. So I replace this parenthesis with R squared times the denominator of that fraction. Okay, k stays the same. Now down here, I look at this and I go, all right, well, this isn't too far off from to this, right? So what I could do, I'm going to go ahead and I'm going to add and subtract n times y bar squared. I'm going to put n y bar squared here twice, adding once, subtracting once. That way I'm adding 0, which changes nothing. So here I've got, the y transpose y minus n y bar squared. All right, well, that looks a lot like that, right? And then here I've got n y bar squared minus, beta hat transpose x transpose y. Well, I notice that this is the denominator of that, and this is the negative of the numerator. That's interesting. And then the n minus k minus 1 is all the same. Okay, well, what I'm going to do at this step, I'm going to divide the top and bottom of the big fraction by this parenthesis here. When I do that, of course, this parenthesis will cancel out. Now I'm down here, I'm dividing. Well, this is the same as that, so that's going to become a 1. And this, well, remember, that is the negative of the numerator of R squared, and then I'm dividing by the denominator of R squared, and I get this. So I know that this is going to be 1, and this is, in fact, negative R squared, and n minus k minus 1 stays the same. All right, so this is R squared divided by k, 1 minus R squared divided by n minus k minus 1. Not too shabby. Okay, so this tells us that there's a direct relationship between the F statistic and the R squared. Okay. Yeah, all right, so something that we can also, we can see in this is that if I think about, think about rational functions, and I think about what happens to R as I add in more and more variables into predictor variables, R squared can only increase when I add in predictor variables. It can't decrease. That comes from its derivation. All right, well, if I focus on this, this is basically a constant with the n minus k minus 1 and the k. This is a constant times R squared over 1 minus R squared. If I keep on putting more and more predictor variables in, then the R squared portion of it, that fraction, can only increase. And so in fact, that will go off to infinity if I keep on throwing in more and more predictor variables, potentially in the limit. All right, so that kind of gives us an idea what's going on. All right, so that also gives us a warning that if I'm overfitting, the F statistic is not going to alert me to it. So be mindful of that as you are building your models in real life. If you keep on throwing in predictor variables, your F statistic is only going to increase. All right, now what about if I want to test about subsets of beta? So here we're interested in a reduced model compared to the full model. All right, well, in this situation, once again, we're using the F test, but how we get that is just a little bit different. Here, I've got, beta hat transpose X transpose Y from the full model. Now I have beta hat transpose times X transpose Y, but this is from the reduced model. And then down here, I have the full model version in there, which is still the same thing. All right, so what am I going to do? It's basically the same game. I'm going to do exactly the same thing. I'm going to add and subtract n times y bar squared, add and subtract. So notice I've got a negative sign here. Negative times negative is a positive, so it would cancel out. So this parenthesis is the same as that parenthesis. All right, well now what I'm going to do, as I've got it into this format, I'm going to divide everything by y transpose y minus n y bar squared. If I divide everything by, y transpose y minus n y bar squared, I'm going to get this, I'm going to get that, and then on the bottom here, I get this. All right, well, let's take a moment. Let's look at that. This is just going to be r squared for the full model. This is r squared for the reduced model, and this is the same as that. So I know this is just going to be, oh, sorry, it's not quite that. This is the same as what we had in the previous F statistic. So this is going to be 1 minus r squared. All right, so here we've got this. So we can see that, my F statistic either way really is a manifestation of our r squared statistic. So testing to see if beta 2 is equal to 0. So that's all of the slopes that we are considering throwing out in our reduced model. Testing to see if beta 2 is equal to the 0 vector is equivalent to testing the reduction on r squared. That's all I've got for you. Take care and goodbye.